This is Mr. Brook. Hopefully you guys had a great spring break. As you can probably tell, I'm not back yet, but this week I'm going to do things a little bit differently. I'm going to make a few videos that'll go through some of the notes that we need to do for our section for Module 14 and keep you guys up to date as far as what's going to happen in class. First of all, you should notice that your test grades are into PowerSchool. So go log online to that, check your grades, see where you're at, see how you did, and then we'll move on from there. Our first section that we're going to work on is primarily going to be more outside of the book than in the book for Module 14. We're going to deal primarily with exponents, and this will give you guys at least a refresher if you haven't done them in a while as far as some of the rules that you need to know for them. First, we're going to review what an exponent is. So if we start with 4 to the third power, the number up top, that is our exponent. All right, and you guys should know that piece. And the 4 is what we call the base. All right, so the exponent is the superscript or the number up top. The base is the main larger number. What this represents, the exponent 4 to the third, that exponent means how many times that's multiplied by itself. So 4 to the third power is 4 times 4 times 4. 4 times 4 is 16, times another 4 is 64. All right, so in your notebook, you guys should be writing this piece down. Make sure you know what an exponent is and what the base is. All right, add to your notes. An exponent tells us how many times our base is multiplied by itself. All right, the next main thing that you need to know is 2 is the same as 2 to the first power. All right, what that really represents is if a constant or variable doesn't have a written exponent, it's automatically an exponent of 1. Same idea that we've had before with the idea of that hidden 1 in front of the x. The hidden exponent is something, if there's no exponent, it's to the first power. That applies to a number as well as to a variable. All right, so we have x, that's the same as x to the first power. All right, another example, we have x times y squared times z. That's the same as x to the first power, y to the second power, or y squared, times z to the first power. All right, if there's no exponent written on those numbers, they automatically have an exponent of 1. Okay. So now we're going to look at a couple of exponent rules, and it's important to note that the rules that we're going to go, these rules only apply to exponents that have the same base. That number has to be, or variable has to be the same. So these exponent rules apply only to like bases. All right, so keep that in mind as you go through some of these. The rules that I want to focus on today are going to be powers and multiplication. So in your notebook, have this down. We're going to have P, all right, down to M, down to A. And what this is going to represent, P is power to a power. All right, power to a power. And if we have something like that, what that's going to look like, you have x squared to the third power. When you see that, you are going to multiply those exponents. So that's the same as writing x to the 2 times the third, 2 times 3 power. Sorry if it's a little bit messy there. We'll try that again. 2 times 3. All right, so that is the same, 2 times 3 is 6, as x to the 6th power. All right, now, so power to a power, multiply the exponents. That gives us to our next piece, when we multiply with exponents. So when we multiply with exponents, an example of that is going to be x squared times x to the third power. So if we're multiplying, we add the exponents. That's the same as x to the 2 plus 3, which is the same as x to the 5th power. All right, so the A for add. So what we're looking at, if we have a power to a power, if we have parentheses, for that, we multiply. If we multiply with powers, we add the exponents. All right, so power to a power, multiply the exponents. Multiplying the two exponents, we add the exponents. Okay, a couple other additional examples. If we look at something like 2x to the third power. So if we look at that, we have a third power there. If you think about what we talked about earlier, neither of these have an exponent, so that's the same as 2 to the first power, x to the first power, all to the third power. Now, we have something to a power to another power. What we do with that, we multiply that through. All right? We have to multiply that through to both exponents. Same as distribution. You have to multiply it to everything. That 3, that third power applies to both the 2 and the x. So this is the same as 2 to the third power. X to the 3 times 1 is the third power. All right? Make sure that applies to both. So another example. If we have 3x squared y to the third, and we take all of that to the 4th power, okay, we're going to make sure that we distribute that 4, that exponent, to everything in there. Okay, 4, so 3 to the 4th power, 3 to the 4th, x squared, and then the 4th power, so x 2 times 4 is 8, so it's x to the 8th power, and y to the 3rd power, and we take that to the 4th power, y 3 times 4 is 12, so y to the 12th power. So as we look at that and simplify that, that's how that's going to look. And a couple more examples with multiplying. If we take something 2 times x squared, all right, we got 2x squared, and we multiply that by 4x to the 3rd. If we look at that, there are no parentheses, so there's nothing that we need to distribute. This is multiplication, so we would multiply the exponents together. If you notice the 2 and the 4, there are no exponents there, so we treat that just like normal multiplication. 4 times 2 is 8, so we're going to write that as 8. All right, x squared times x to the 3rd. We are going to add those exponents because it's multiplication. So we have 8x to the 2 plus 3 power, which will end up being 8 times x, 2 plus 3 is 5, to the 5th power. All right, multiplying, we add our exponents. So for the worksheet that you guys have today, we are going to focus on multiplication and powers to a power. So it's going to follow along with some of these examples that you looked at here. So work on the worksheet, check your answers, make sure you're on the right track.